Good morning, good afternoon, and good evening. Welcome to the 2022 NASA Earth Science Applications Week. This week, we'll celebrate the many ways NASA Earth Science helps make our world a better place and celebrate the official 50th anniversary of the Landsat program. Thank you so much for joining us from across the globe. My name is Ryan Hammock. I'm a fellow with the NASA Develop National Program, and I'll be your MC for our first event this week. I'm so glad you all have joined us for our third virtual event of this scale. This year, we are very happy to report that we have an even larger turnout than last year, with over 1,500 registered attendees joining us from 65 countries. We hope you are all excited as we are to jump into a week full of engaging events, including project highlights, guest speakers, both from within and outside of NASA. You can find the complete agenda and links of all the events on the NASA Earth Science Applications Week event webpage. Should any changes occur throughout the week, the most up-to-date schedule can be found there. For a brief summary, we will kick off each day with sessions from 1 to 4 p.m. Eastern Time on WebEx, the same link that you used to join us today. All events this week can be joined directly from your browser, and the links are available on the event webpage, or in a confirmation email rather, that you will be able to visit. Given the number of attendees, speakers, and events we have occurring this week, we would like to thank you in advance for any patience and in the event we encounter technical difficulties. But just a few housekeeping items before we get started. Everyone should make sure that you remained muted with your camera turned off. We hope that you use the chat function for any comments you may have, in addition to any questions you have for our speakers out there. We can all start off by typing in the chat where in the world you are joining us from today. But with that, without further ado, it's my pleasure to introduce our first speaker, Lawrence Friedel, the director of NASA's Applied Sciences program, who will share some opening remarks.
Great, thank you, Ryan. As Ryan said, I'm Lawrence Friedel. I'm the director of the Applied Sciences program in the Earth Science Division here at NASA headquarters. I have to say, our team has one of the best jobs at NASA, maybe even in government. Everything we do is about helping people use NASA's vast information and data about the Earth to improve the quality of life in communities here in the U.S. and around the world, frankly. So it's about putting Earth science in action. It's absolutely a great mission, and I have to say it's a fantastic team. They are driven about creating good in the world: health, conservation, food security, water resources, and lots more you're going to be hearing about all week long. And while we're putting out stories all the time about ways that our partners are using Earth science data in all these interesting, creative, and really beneficial ways, this is the best week of the year for us. It's really a chance to showcase so many great things that are going on across the program. And it's really just lots of examples about what we do and how we do it, frankly. And our activities, we realize they're just part of the broader Earth science efforts at NASA. So developing sensors, building satellites, collecting and sharing the data, researching phenomena about the Earth, and building models to sort of codify our understanding, and really sort of, just supporting predictions that other organizations need. And so all of it is part of helping people use scientific insights for their benefits. And really, in fact, actually, those sorts of statements are in the founding legislation of NASA. So again, it's just a fantastic mission. Now, let's take the term Earth science applications. Some of you may be thinking, what's an application? Don't worry, we get that a lot. And so we think of an application, it's the use of some NASA scientific data to inform a decision or to guide some sort of action. It's things like where to site a solar farm, or when and how much to irrigate some crops. It's where to prioritize sending relief funds or maybe generators after a disaster. Or maybe it's to how to allocate resources or to help decide which land to conserve. Now, at NASA, we don't own these decisions or those sorts of actions. And so everything that we do is in partnership with other organizations. companies, nonprofits, government agencies at the state, local, federal level, tribal level. And so those people, those organizations, they are the practitioners. And so what we're doing with these applications, we're helping these organizations apply that our data in their business activities or in their day-to-day management or in the planning that they're doing or in the policymaking process to see if the information that we have helps them to make improvements in what they're doing. And so when and where it does, we're helping them to adopt and sustain the use of the information that we have. And so it's these benefits and the impacts that are the real rewards that we're sort of seeing. It's really when a farmer saves money by using less water and getting better yields or higher quality crops. It's when there's fewer cases of West Nile virus because a health department targeted their mosquito control efforts in a better way. Now, with NASA, we fully recognize that the focus is often on the technology and the highly technical parts, some of the things I mentioned earlier, the satellites, the sensors, the data, and those are fundamental to what we do in applied sciences. Yet, with applied sciences and with applications, it's really just half of it. There's a whole part about engaging with organizations and engaging with users. It's building dialogue and working together. And so people talk about this term co-production. It's where scientists and practitioners build this dialogue and they work together on issues. And so it creates this sort of real sort of back and forth. And there's different kinds of collaboration and there's different kinds of co-production, I mean. Some kind is more of a collaborative nature and really sort of this collegial. Some of it is more consultative, or in some cases, a bit more sort of ad hoc in nature. And you're going to see very different kinds of it this week across the different examples. So it's really something to watch out for. Now, sometimes people ask me, what's your favorite application? And I have to say, here's some things that I think make for some really, really good applications. One is having a great partner. It's an organization that's willing to try something new. It's an organization where they know what decision that they're trying to improve. They're willing to take a risk. They're willing to iterate to sort of see how and whether the earth science information can help them. A second item is really just a creative use of science and a creative use of this earth observing data. And so I absolutely love it when people sort of say, I didn't know you could do that from space. I didn't know NASA could measure that from space. So I love hearing those sorts of things. It's that surprise element. And then the third element is having clear benefits. Now, whether it's qualitative or quantitative, not really as important. It's really just sort of, it's where people can agree that there was a clear improvement and there's a desire to sustain that going. Now, there's lots of applications that we've enabled that have all three of these aspects. But to get back to that question I asked earlier, when people ask me, what's my favorite application? I have to say, my answer is always the same. It's the next one. We're always looking to sort of see what's a new partner or a current partner that might want to do something else with us. What are some new science? What's kind of emerging? What insights is that providing us? What are other ways that we can be sort of showing the benefits and the impacts? And in that, because it's the partner's benefits, how can we showcase what the partner's doing to serve its clients and customers in these beneficial ways? Now, to bring it back to Earth Science Applications Week, there's going to be a lot going on. There's going to be lots of different examples and panels and uses of earth science information. And when you hear about the applications, really, based on some of the things I've just said, encourage you to be listening for and looking out for, who are the partners? What are the types of decisions? What's the scientific data that's being used? What's the mode of co-production or the type of collaboration? What are those benefits? Now, I have to say, throughout all of this and throughout the week, hopefully you're going to be able to join us each day. If you hear about something and it sparks an idea for how you or your organization might be able to use earth science information, please contact us. If you hear about another organization that's using earth science data in a way, and you think that your organization could do something similar, please contact us. That's what we're here for. Now, I will say that in the last few months, we released something called the Earth Science Applications Guidebook. It's essentially a manual on how to do earth science applications. It's got lots of lessons learned, and it's got a lot of the knowledge that we've gained by doing this over decades. It's available on our website, appliedsciences.nasa.gov. And on Thursday, we're going to have a special session focused specifically on the guidebook. So there'll be a lot more information there. Now, one of the things I want to be really, really clear about is that we know that we don't get any of the applications that you're going to be hearing about. Any of these earth science applications are building on the tremendous amount of work that goes on in the other parts of the earth science division. And so it's everything else that they're doing on the sensors, the satellites, the technology, the data, the research, and all that sort of stuff. And I have to say, it's a fantastic internal collaboration within the earth science division. And so it gives me great pleasure to now introduce Dr. Julie Robinson. She's the Deputy Director of the Earth Science Division, and she can tell you more about that. So over to you, Julie.
Thanks so much, Lawrence. Welcome to the third annual NASA Earth Science Applications Week. I am really thrilled that I can join you all virtually for what will be a fast-paced and really exciting week. I want to start off by thanking the Applied Sciences team led by Lawrence, and they're just so enthusiastic, and they coordinated this event. I'd also like to extend NASA's thanks to the many partner organizations and the different NASA centers that support this work. Without all of you, we would not be able to accomplish the meaningful achievements together that you're going to see talked about and shared throughout the rest of the week. In the Earth Sciences Division, we get to spend every day exploring. We study the Earth from new perspectives, understanding the biggest picture, sometimes the small details, and we think about the systems of the Earth that influence our daily lives. By leveraging Earth observations from satellites and from airborne campaigns, we can better understand the dynamic and interconnected nature of our planet, all to help inform decisions on the ground. With new technologies and new applications, we're always finding new ways that scientists and non-scientists alike can use NASA data in their research and, most importantly, in their decision-making. We need to communicate those possibilities to communities around the globe so that the whole world benefits from this unique perspective. And that's where Applied Sciences comes in. Each year we work with more users than ever before, across sectors, in new geographical regions, employing new technologies, and we always seek to integrate science and society into one whole. Over the next 3 days, you will see talks highlighting NASA Earth Science data covering the entire globe, all kinds of topics, all presented by our team, which includes everyone from Zoomers to Boomers. One highlight of the week is the DEVELOP program. DEVELOP is a 10-week experiential learning program that builds skills and knowledge in Earth observations in young professionals. It's something we're really excited about, and many thanks to the DEVELOP leadership team for their hard work in making the summer term a virtual success for those students. We will also hear from members of our Applied Sciences team, highlights from Surveyor and ARSET, upcoming mission teams, including PACE and TEMPO, NASA Harvest, and from our partners at USGS, where we are celebrating with them the 50th anniversary of Landsat, our longest running mission and really a symbol of the transformation of the Earth that can be studied from space. We'll close out the week with ways that you can get involved through training, competition, and practical guides for applying what you've learned this week. It's a great opportunity to learn and interact with so many passionate people and learn about and help find more innovative ways to use science to benefit society. So to the project partners joining us, we hope that you will learn not only from the project and team that you're engaged with, but also from the many other examples that are presented this week. It's also a great opportunity to connect with NASA centers, young researchers, and data users. So please feel free to connect with one another in the chat, carry on the conversation, keep connected beyond the event. With that, best of luck to all the presenters this week. I'm really excited to see everything that's coming, all the new innovative approaches that will be presented, and especially the partnerships that we'll see throughout the week. Have a great week, and welcome to Applications Week.
Great. Thank you so much, Dr. Robinson. Now we'll turn it over to Deputy Director of NASA's Applied Sciences Program, Dr. Emily Silek-Glassman, and Applied Sciences intern, Kara Crosby, to learn more about the Applied Sciences Program.
Thanks, Ryan. I'll just echo first what Julie and Lawrence are saying, in that it is such an exciting privilege to get to talk to all of you here today. I'm seeing the number of participants tick up and all of the countries that you're all in, and gosh, it's just one of the most thrilling parts of what I get to do. Okay, so next slide, please. Let's see. So I'm going to talk about the 3 lines of business that Applied Sciences has. I'm going to start, so we've got 3. The first is our innovative and practical applications, where we're developing, testing, proving out, and then ultimately transitioning to our end users, to our partners, and transitioning those uses of earth science information in decision making. I'll also spend some time talking about our second line of business, which is our capacity building program that's looking to build the capacity of individuals and organizations and institutions, both domestically and internationally, to use Earth observations. And then at the very end, I'll touch on a little bit of the work that we do in terms of our mission planning and mission engagement, where we're trying to infuse the consideration of applications throughout mission life cycles. Next slide, please. So what are our application areas? I know Lawrence defined applications. Our application areas are thematic program elements. So they each cover a different area in which we think earth science information can serve society. So we have some of our program elements here, our application areas that have been around for a long time. You'll see, you might be familiar with our disasters program, our health and air quality program, water resources, ecological forecasting, and agriculture. One thing that's been really exciting in the past years, we've been starting up 3 new application areas, one along on the topic of wildland fires, one on the topic of climate and resilience, and one on energy. Next slide, please. So we have all of these different areas in which we're applying earth science information. What do these have in common? It's really this focus on decision making. We're looking to help others use satellite data and information as evidence for different types of decisions and actions. And I'll walk through a couple of examples, since I think it's helpful to get a little concrete on these to know what we're going to be talking about the rest of the day. So one example is using earth science information for planning, management, and response. And a great example of that is the use of earth science information to create damage proxy maps after disasters and work with disaster response managers. So over on the right, I'm showing a picture of an example damage proxy map that was developed by the ARIA program, and it was looking at an earthquake that occurred in Peru about a year ago. And in red, these were areas that were estimated to have quite a bit of damage. So you can imagine, if you have that map and you're a disaster response manager, you know where to target your intervention. And it's that earth science information, it's that seeing that change over time where buildings might have collapsed, and so now there's an elevation change, or there's debris, and so now there's a difference in what kind of sunlight, what colors of sunlight are reflected, that allow us to create this type of information. Next slide, please. So another type of way that earth science information can help is in monitoring and tracking impact. So here's an example of a monthly crop product. This is put out by the GeoGlam. It's an international collaboration where they're using earth science information to look at crop conditions around the world. Because if you know where crops are doing well and where crops aren't, you can start to intervene and start to plan to move resources around and potentially avoid famine. So this is incredibly important, and it's because we have information about drought, and we can see things like soil moisture, and we can see where crops are green versus brown, that we can do products like this. Next slide. So another common use is for alert systems. So this is showing a product called Cyan, which was a project between the NASA Earth Science Division and the EPA, the U.S. Environmental Protection Agency, that provides early warning on sickening algae blooms in lakes. So this is something where water resource managers don't have to do the type of time-intensive and lengthy testing when we have satellites that are passing overhead and can look at reflectance and provide that early warning for folks. Next slide. So if you take away one thing from this, I would say, and this is really building on some of the comments that Lawrence was making, it's the application projects that have users participating throughout the development process. Those are the ones that will make an impact and endure. So we have lots of different mechanisms to do that depending on the particular need of the project. We have about 100 individual grants going on at any given time. Those are done in partnership with user organizations, and sometimes they're even co-funded by user organizations. So you can see all of the solicitations for grant proposals, not just applied sciences, but all of the ones through the Science Mission Directorate at NASA at the Research Opportunities in Space and Earth Sciences, or ROSES. Sometimes we need to have longer term relationships built where we can then start and stop projects on a little bit more of a dynamic, agile basis. For those efforts, we've actually started up consortia. So we've got two right now in our application areas. One, our agriculture consortia is called NASA Harvest, and we have a Western Water Applications Office as well, or we call it WAYO. We also have a method of working together to have these problem-solving teams where we're really looking to team researchers with, in this case, health and air quality managers to collaborate on important and urgent topics. And so that's where we have the Health and Air Quality Applied Sciences team and HAYCAST. So all of these different mechanisms, we try to figure out what's the best mechanism for the type of problem, but for all of them, we're looking to engage users throughout our development process. Next slide, please. So I'm going to talk briefly about the capacity building program. So as I mentioned before, this is looking to build up the capacity of individuals and institutions to use earth science information to in their own decision making. So we have kind of three flagship lines of effort there: RSET, Develop, and Surveyor, and an exciting and growing Indigenous Peoples pilot project as well. If you could go to the next slide, I'll go in a little bit more in depth. So RSET is our remote sensing training program. We have online and in-person trainings, live and on demand. Oftentimes you can find in the archive as well trainings that have occurred. And they go from very, remote sensing 101 to very advanced, timely topics that we're hearing in the community are really important, and everything in between. And the training materials are not only offered in English, but to an increasing degree in Spanish as well. So I really encourage you to take one. You might meet someone you know, because these RSET trainings have reached so many people, 20,000 participants from 160 countries. It's pretty staggering. Next slide, please. As you've been hearing, we have a lot of developers in attendance. Our develops are our 10-week feasibility studies where we have teams of often early career folks working with partner organizations, maybe NGOs, maybe local governments, to solve a problem. And it is astounding what they accomplish in 10 weeks. One thing that's been really exciting to see is the work that they've been doing in environmental justice, particularly with Groundwork USA. Some great talks yesterday. I'm sure we'll hear more, but if you're thinking, how can I get my feet wet and dive in a concentrated amount of time, highly recommend checking out Develop. Next slide, please. Okay, and Surveyor. So Surveyor is a joint development initiative of NASA and USAID. So there are 5 regional hubs around the world, and what they're hubs in partnership with regional organizations to help those regional organizations build up their own ability to use earth science information. So they take a service planning approach that I think is really impactful and pretty unique, and it really gets products and services in the hands of decision makers all over the world in disasters, agriculture, water, and ecosystems and land use. Next slide, please. So at this point, I'm actually going to hand over the virtual microphone to Kara Crosby, who's one of our diversity, equity, inclusion, and accessibility interns. It's been a tremendous privilege to get to work with all of our DEIA interns over the past, I think we're at 2 years now. They've really brought in so much knowledge into our program. So at this point, over to you, Kara.
Thank you, Emily. So I'm just going to briefly go over some of the projects that the Applied Sciences DEIA team is involved in. First of which are inclusion activities. So they look to increase inclusion via executive order strategies. These would look like lunch and learn discussions, as well as building knowledge management systems. So all of the diversity and inclusion teams here at NASA can share information in an efficient way. We're also involved in some minority serving institution engagement projects. So we look to develop engagement strategies so current and future Earth science missions can engage with MSIs more effectively and strategically. We also hold interactive DEIA series, so we develop and facilitate diversity dialogues to increase diversity and inclusion here at NASA. Next slide, please. We also were involved in the 2021 Space Apps Hackathon Challenge, which focused on environmental justice. So this really increased global environmental justice engagement via gamification, such as a hackathon. We also are involved in diversity and review panels. So we consider diversity and inclusion within project proposals themselves. And we also consider diversity and inclusion amongst the panelists as well. We are also involved in some demographic data analyses in Earth Sciences. So we collect and analyze internal demographic data to assess whether or not our DEIA goals are being met. So that really just provides us with a nice benchmark to see if whether or not we are achieving our goals and moving forward in the way that we anticipate. Thank you.
Thanks, Kara. So I think I'll just end on a note of we want folks to join us. So if you're just ready to learn more about how to do applied sciences or even how to think about applied sciences, because while we do applied sciences here at NASA, there are lots of other venues you might want to pursue as well. Please do check out our Earth Applications Guidebook. It's multimedia, it's really engaging. You can hear from program managers, project managers about what's worked for them and learn about, what I really like about it is it shows a diversity of different approaches and pathways to make an impact. If you're looking for grant opportunities, take a look at the list of solicitations. Kara mentioned the Space Apps Challenge. This is a Science Mission Directorate-wide effort, but there are always applied science challenges there. So if you want to form a team and help us solve a problem, take a look there. Right now, we also have a comic strips challenge. So if you are an artist or if you know an artist, check out that. As we mentioned before, please do take a look at our RSET training calendar, consider taking a training, or consider becoming an early adopter of new mission data, where you can learn and provide feedback to NASA on how our new missions could serve your decisions. So thank you all for this opportunity, and thank you to all the people who are putting the relevant links in the chat. That's tremendously helpful. I think I have my last get off the stage slide with contact information, so please don't hesitate to reach out. And with that, I will hand this back over to Ryan.
Wonderful. Thank you so much for that fantastic overview of the NASA Applied Sciences program. So just if we could go to the next slide, as a quick overview for this week, we will be meeting here on this link that you have for today, tomorrow, and Thursday from 1 p.m. to 4 p.m. Eastern Time. Each day will include a wide array of thematic sessions ranging from environmental justice to celebrating the 50th anniversary of Landsat. Again, for a full detailed agenda of this week's activities, please check out the Earth Science Applications event page on the NASA Applied Sciences website. So as we approach the end of our overview session here, we will now transition into a break, and we will begin our first thematic session focusing on health and air quality applications. in about 30 minutes at 2 p.m. Eastern Time. So we look forward to seeing you all join again in about 30 minutes. Thank you.
Around the world. As Nicole mentioned, I'm John Haynes. I serve as Program Manager for NASA's Health and Air Quality Applications Program, and I'm going to give just a brief overview of our program today to you before we jump right into our exciting roster of panelists. Let's go to the next slide. Nicole, the slide doesn't seem to be moving on my end.
Some technical difficulties, John. We're working on it.
No problem. No problem. I understand. I'll just go ahead and speak while we're getting those slides up and running. The mission of NASA's Health and Air Quality Applications area is to support the use of Earth observations in air quality management and public health, particularly regarding infectious diseases and environmental health issues. We also promote the use of Earth observing data and models regarding the implementation of air quality standards, policies, and regulations for economic and human welfare. We address issues of toxic and pathogenic exposure and health-related hazards and their risks and effects on health, while also as an umbrella issue addressing climate change and its effects on health and air quality to support managers and policymakers in their planning and preparations in the years and decades to come. Now, currently, I'm proud to say that the Health and Air Quality Applications portfolio is the largest it's ever been, with over 30 projects. So we have a myriad of partners and stakeholders across the nation and around the world. And that includes both in the public sector, both at local and state levels, as well as regional levels, also with federal agencies and international agencies, but also in the private sector with companies such as AER Incorporated and nonprofits like the Moore Foundation. So if you were seeing my slide up, which I don't think you are yet, but I was just listing on the next slide some of our major partners across those sectors. And those include such folks on the international level as the Group on Earth Observations, the World Health Organization, several UN agencies. On the federal level, we work very closely with the Centers for Disease Control and Prevention, the Environmental Protection Agency, and the National Oceanic and Atmospheric Administration. And we also work with a myriad of state departments of environmental quality and departments of health. Now, in all of our projects, we like to promote what's known as the concept of One Health. One Health means that we're taking a holistic view of health, not just human health, because we must recognize that human health is connected to the health of animals and our shared environment. This is a concept that has now percolated throughout the health community, and it's very important for us to get a representative viewpoint of how our entire planet is connected and how that affects all of us, all of our health and well-being. Okay, I see our slides are back up, so let's go to the next slide. One of the projects that I just wanted to highlight for you today, and you're going to hear a lot of new projects going on over the next hour, but this project was really exciting this summer because this was a project led by Dr. Pablo Mendez Lazaro at the University of Puerto Rico Medical Sciences campus in San Juan on forecasting poor air quality events in the Caribbean related to Saharan dust. Now, what was so exciting this summer is that this project hit ARL 9. Now, what does ARL 9 mean? Well, it means that this project and its tools that were developed using NASA satellite data went to operational sustained use at the partner organization, which is NOAA, and their office in San Juan. Now, why is Saharan dust an issue? Now, Saharan dust storms cross the Caribbean regularly, and they adversely impact air quality and human health. Dr. Lazaro joined together a very robust team in Puerto Rico, including NOAA, the EPA, as well as the Puerto Rico Department of Health, to build an operational air quality forecasting tool to inform policy decisions, educate the public, and safeguard population health. And this new operational air quality forecasting tool for Saharan dust gives the island of Puerto Rico 3 days of advance warning of when these dust storms are going to hit. Now, this system went into its experimental launch in June 2020, and let me tell you, it was just right right in time. Because as you can see here, in June 2020, the largest Saharan dust storm in 50 years hit the island of Puerto Rico. And thanks again to Dr. Lazaro's system, using data such as aerosol optical depth from the SUMI NPT satellite, the island had 3 days of advance warning of this major storm. Let's go to the next slide. Oh, and that slide disappeared. But on that next slide, what you will see is that the aerosol tool that Dr. Lazaro and his team have developed is now operational on a NOAA platform known as the Caribbean Ocean Observing System, or CARICOOS. And this operational forecast, which you can visit right now, is also tied to the Puerto Rico Department of Health's air quality alerts and the health interventions that they recommend for the public during those different severities of dust storms that hit the island. Let's go to the next slide. And finally, I'm just going to mention this really exciting satellite that we're going to have launched in 2024. You're going to hear about another really exciting air quality satellite later in the hour called TEMPO, but I want to mention Maya as well. Maya is known as the multi-angle imager for aerosols. It's a satellite mission being developed by the Jet Propulsion Laboratory in Pasadena, California. And Maya is representing the first time that NASA has ever partnered with epidemiologists and health organizations on a satellite mission to study human health and improve lives. Maya is going to be in low Earth orbit, and it's going to target megacities across the globe. And these megacities were chosen because health cohort studies are ongoing in those cities, being led by epidemiologists on the ground. Maya will be looking at particulate matter and speciation of particulate matter. And thanks to those observations, plus these health cohort studies, we're hoping to assess linkages between particulate matter and different types of health effects, including birth outcomes, cardiovascular and respiratory disease, and premature deaths. Again, really excited about Maya. It's going to have great synergy with the TEMPO observations, which you'll hear about a little later. We're expecting that to launch in 2024. And with that, I'm going to end there. Thank you for your time. I hope you stick around for the rest of the hour and for the rest of the week and hear all of these great and exciting projects through Applied Sciences. And I'm going to turn it back over to Nicole to MC the rest of the session. Thanks, Nicole.
Thank you so much, John, and thank you for that introduction. Now we're going to transition to our next speaker, Dr. Ben Zaitchik, who will talk about the global distribution of Shigella infection risk.
Power to unmute. There we go. Thank you. I did not have the power to unmute. All right. Thanks so much. Real honor to be part of this session. So yeah, presenting on behalf of some great work really done primarily by Josh Colston and Hamada Badr, who are the research scientists who really led a lot of the analysis here, and also on behalf of my co-principal investigator on a lot of this work, Margaret Kosick. So move on to the next slide, please. So Shigella, for those who are not familiar with it, is an enteric infectious agent that really has a tremendous burden around the world. Now, this estimate, 160 million people per year, comes with a big caveat, which is that we really don't know. So the rough estimate is that it's causing, more than 10% of the annual diarrheal disease deaths from children under 5. And of course, diarrheal disease in children under 5 continues to be a leading cause of death worldwide. So we know the burden is substantial. We aren't exactly sure what it is. Next slide, please. And why don't we know what the burden is? Because it's really rare to find studies of this. So particularly now, as we're on the cusp of having some vaccines being ready to be deployed for this particular pathogen, we really need to understand in a pathogen-specific way what's causing enteric disease. Very often you just get this non-specific presentation of severe diarrhea and dehydration, and you don't know whether it was a viral or a protozoa or a bacterial infection, whether it was an E. coli or whether it was Shigella. And so without knowing that, it's very difficult to target your interventions. So next slide. The work that we're doing, however, was motivated by the fact that people really started taking these measurements in a serious way. We started off with a collaboration with the MAL-ED study that was originally supported by NIEHS, or the NIH, that was at sites around the world trying to sequence the bugs in the guts of these kids, taking stool samples from healthy kids, active surveillance, healthy kids, sick kids, panel studies over time. And what we found in the course of the study is that there was MAL-ED, there was GEMS, that was another big one, But also we were able to connect with partners around the world who were running their own kind of surveillance studies in which they were typing the infections, all right? And so what you're seeing on a map here is simply a location of all the sites we were able to include. If you hit the next slide button once, I just want to point out that this took a tremendous amount of work. So this is we just posted on as a preprint the paper on this, and this is the author list, which is something I'm pretty proud of, and a huge kudos to Josh Colson for coordinating all this, but also a huge thanks to all of these site managers, physicians, and everyone around the world who were able to collect amazing data and contribute it to this kind of study. Next slide. And so what did we do? So we took these great data that we had from about the pathogens, about the infections, and then we combined it with our Earth observation data and data from other sources. So here, these are just 8 hydrometeorological, daily time varying fields that we were able to use. We leaned on GLDAS, the Global Land Data Assimilation System, a lot. We also used CHIRPS, happened to be the precipitation product we were using. Looked at multiple sources. Next slide. We combined that time-varying hydrometeorology data with some static data. And now on this slide, I'm showing landscape and human systems. And most of this, the majority of this is remotely sensed as well. Okay, so they're quasi-static or slowly varying when you're looking at things like vegetation, land use, elevation, cropland area. But again, it is Earth observation. And so these are also data we were able to leverage. Next slide. We then combined those Earth observation-derived characteristics with what we're calling household factors. This is your traditional global health data collection, right? What's going on? What's the flooring material in a home? Are the children breastfed? These kinds of details that are traditionally associated in studies of enteric infection. And then Josh has a paper on this where he's able to map this out quasi-globally based on available data sets. Next slide. So we took all of those, all right, and we put them into a predictive modeling framework. And this is just a variable importance plot. Don't need to worry about the details. We're showing 2 different metrics of variable importance. That's why you see 2 different bars for each one. But what I want to emphasize is that those top 2 bars, the big ones, child's age and study design, those are your control variables, right? You just have to have those in the study. Then you start looking at the other ones, the ones that are explaining variance beyond those control variables. Air temperature, wind speed, relative humidity, soil moisture, all of these hydrometeorological variables that were not previously included systematically in these kinds of studies end up explaining a lot of variance. Look at the next 3. Remotely sensed variables, irrigated areas, cropland areas, enhanced vegetation index. It's not until you get down to like the 10th variable or something where in purple, sanitation facility, you're seeing these traditional metrics show up. So the Earth observations are providing just tremendous amount of power in terms of predictive modeling of this infection. Next slide. And so in terms of thinking about how we present this to our colleagues in the global health world, this is this will be familiar for people who do statistical modeling, but the point here is these are different accuracy indicators, all right? Higher is better for everything except specificity, where lower is better. And the control linear model, control GLM, is if you just use your control variables. And then we say, well, what if we add in our static variables, right? Including things like vegetation indices, irrigated area. That's the green. You do a lot better. What happens if you add in your hydrometeorological variables? You do better still, that's the blue. What if you allow for nonlinearity or modeling? Because you're dealing with communities here who have some healthy suspicion for advanced statistical techniques. When we go to the generalized additive model in purple, that's where we get the best performance. And this is out of sample prediction. Next slide, please. And just to emphasize, we can also understand what the impacts are here. And so this here is just showing an odds ratio. If it's to the right, if it's greater than 1, then an increase in the variable is generally associated with an increase in risk. It's nonlinear, but this is giving us a general increase. And so you can see how these play out. I don't have time to walk through all of them, but we end up learning some interesting things in terms of what's protective and what might not be. And so, for example, there were some prize results on open defecation and things that we'd love to talk to about more, but not in the interest of time. But we can actually infer process here. Next slide. And we also get these kind of nonlinear response plots, to which focusing here on the hydrometeorology and seeing things like, one would think that bacterial infections generally, you see them more when they're warmer and they're wetter. Well, here we're seeing for air temperature in the top left, that's generally true, but it does max out. Okay, so Shigella has an optimal range, and we're seeing that here in the data for asymptomatic as well as symptomatic cases. And then we're seeing, as expected, these increases in relative humidity, soil moisture, going up with higher rates, and then solar radiation, interestingly, is a positive association, which we think is primarily associated with geography. Next slide. Okay, and you can also look at these interaction terms. That's a great thing about this advanced modeling. And what hopefully is clear here, though I know there's a hard plot to look at, is that precipitation deviations matter in different ways depending on what your antecedent soil moisture is, right? So it's a classic situation of rain on a wet soil, right, leading to overflow events and things like that. And you absolutely see that here, whereas you get to higher soil moisture, the influence of precipitation ends up taking on this different, pretty severe character. Next slide. Okay, and so this is kind of the punchline in some ways. What we have here are estimates of prevalence globally, all right? And this has not been done before, right? And so now we know the general burden of Shigella, we think, based on spatial inference using our predictive model, for both medically attended as well as community detected and asymptomatic. Next slide. And the other point of this is we know the geography, but we also know what happens through time. And so this is a day-by-day animation for 1 year. That's just walking through where we think the seasonality is going on, where maybe some acute weather extremes might be influencing risk conditions. So when it comes to getting out interventions, maybe thinking about prioritizing vaccines geographically and seasonally, hopefully this kind of information can be of use. Next slide. Great. And this just summarizes that seasonality result, maybe a more digestible way. In what month do you find your maximum risk anywhere? And how significant is the seasonality, right? Do you really need to time the seasonally, or are you in a situation where it's kind of there year round? Okay, next slide. All right, so I'll finish up there, simply just pointing out that we're pretty excited about these results. We've shared them with, simply sharing them with our authors was a good end user group, but of course sharing it beyond that. And we really hope this will be useful for existing interventions and as well as for vaccine strategies as these vaccines hopefully come to the market in the coming years. And I believe that's all I've got. Thanks so much.
Thank you for sharing that interesting work, Dr. Zaitchik. It was great to hear how Earth observations can inform work on Shigella infection risk. So next we'll hear from Dr. Jenny Bratbird, who will provide an overview of the Health and Air Quality Applied Sciences team.
Okay, great. Thank you. I'm really excited to be talking about HAYCAST today. I am the outreach coordinator for HAYCAST, filling in for Tracy Holloway, our team lead. And so next slide. So first of all, what is HAYCAST? It stands for our Health and Air Quality Applied Sciences team. It's a 4-year initiative running through 2025. We have 14 members and over 70 co-investigators. Our mission is to connect NASA data with air quality and health applications. And we do this through 3 types of work. One is through our member projects. So each of our 14 members has their own project. We also have our Tiger Team projects, which are highly collaborative projects, a little more focused. And finally, we have outreach, engagement, and rapid response projects. Next slide. So HAYCAST to me, as an outreach coordinator, having been involved for the last year, is just amazing. There's a really wonderful community here. Part of that is because this has been running for a long time. It started as ACAST in 2011, the Air Quality Applied Sciences team. Health was added in 2016 in the 2nd generation, and now we are on the 3rd generation. And the team structure really helps change the outcomes. It helps increase the visibility of work to reach more end users. It really develops this culture to support and promote collaborations, focused on stakeholder needs, growing the dialogue, and helps rapidly spin up high-value activities. Next slide. So I'd like to introduce our 14 members here. I won't be able to list them all out, but you can see their names here. They're coming from all over the country, from Alaska to Florida, covering a pretty wide range of air quality research and health research areas. And I'll just point out, Pawan Gupta's here today. He'll be speaking later today. And it's through the amazing efforts of these researchers that HAYCAST is able to achieve the work that it is. So it's been really wonderful to work with these folks. Next slide. The other part of the equation that makes this work possible is with our partners and user community. And I'm really excited about this program we launched this year called our HAYCAST Ambassadors. where we're engaging high-level stakeholders who are committed to advancing NASA data for societal benefit and who have signed up as being willing to serve as liaisons to their community. And I think it really speaks to how welcoming this community is, how useful it is for users, that when we launched this a couple months ago, we had so many people sign up right away who are so involved and really willing to give their feedback and input. And I'd also like to draw your attention to the end users, where they're coming from, which is a whole bunch of different communities, including state and regional states, air quality departments, federal agencies, including the EPA, the Department of State. We have a lot of health-based nonprofits like the American Cancer Society and the Health Effects Institute, and also private companies like Brisometer and IQAir. And so each of these folks is really happy to share a lot of examples of how they're using data and bring it back to their communities. So we're excited to see how this continues to develop. Next slide. In addition to engaging with our ongoing partners and people who have been involved, some for a very long time, we're also constantly reaching out to new partners, for example, with articles to people who have never used satellite data before, like this. Next slide. And with our website, where we have a variety of tools. Next slide. And I think it's for these reasons HeyCast has been so successful with both outreach to new users as well as very sophisticated users with a lot of dialogue to help address their health questions and needs. And it's been highlighted as one of a good example of this making open science work. Next slide. So I mentioned that we have the 14 member projects that are running through the entire course of the initiative. We also have these highly collaborative Tiger teams. So multiple HeyCast members get involved along with stakeholders. These are much more focused and short term. And they're very much stakeholder based. And by that, I mean that stakeholders are involved in about every step of this, from brainstorming. They also help review the proposals themselves, give a lot of feedback on that, and they're involved in the projects themselves. So right now we're on our first round of Tiger teams. Next slide. And currently we have 5 Tiger teams. They're all really exciting. I wish I had more time to talk about all these different projects. I'll highlight that the Satellite Data for Environmental Justice team has been highly collaborative, great at capacity building. And if you're curious to hear more in the next session, Gage Kerr will be talking about this in more depth. So stick around. We also have a variety of other teams focused on different areas, including helping make data products easier to access and use. We also have a team specifically focused on nitrogen oxides emissions, particularly for sort of the urban planning aspects and understanding how to convey the uncertainties. We also have a collaboration between EPA, NOAA, and NASA, working with EPA's AirNow system, which is a very popular tool. And this team is working on incorporating high-frequency satellite air quality data into that to make it even better. And finally, we have a team specifically focused on agricultural fires, because there are a lot of communities dealing with smoke from these fires, and they're very curious about what are the health impacts and understanding that better. So this team is really going to take that on using fused Earth observations. Next slide. I also want to briefly mention our rapid response projects, which is a new initiative here. It's even shorter term than the Tiger Team project. That's really helping partners with developing that have ongoing issues and they need a rapid response. So we're really excited about this. These are just in the very beginning stages. One example I'll highlight is a project being developed in Alaska in response to the huge wildfire season they've had, developing better smoke forecast with deep learning algorithms, which is being led by 2 HeyCast members, including Jinku Mao from Alaska and Pawan Gupta, as well as working with a stakeholder in disseminating the data through apps with a stakeholder from Brisometer. We also have other projects that are going to be starting up too, including working with the New Mexico Department of Health responding to wildfires and extreme heat, as well as a project with multiple stakeholders interested in looking at pollution from warehouse-related transportation. So stay tuned. These will be developing soon. Next slide. Finally, I'll highlight a couple of examples that I think cover kind of some of the breadth here. So for example, late last year, there were a lot of questions about the shipping backlogs that were happening at ports and what effect that was having on air quality. So some HACAS members were able to dive in on that and look at it. And specifically, we had a member whose individual project was focused on ports. That's Ted Russell, who really helped with this too, along with other folks involved, and able to make these really nice figures to display how air quality is being affected. Next slide. We've had some great developments this year of new satellite-derived global data sets. So highlighting this publication from Susan Anneberg that garnered a lot of attention. They're looking at concentration of nitrogen dioxide and how that was linked with pediatric asthma, and specifically with a focus on urban areas throughout the world. So a really big health interest to a lot of stakeholders, and very impactful. Next slide. And finally, I'll wrap up with another example that I think is a good showcase of how NASA data can be incorporated into models. So in this case, Air Quality used it to make their custom models around the Great Lakes to track ozone pollution. So again, a great usage of this data meeting a specific stakeholder need. And I hope you can see from these examples that there's a lot of different ways that this can be used. And I'm really only scratching the surface of a lot of these different HACAS activities. So if you're interested, please feel free to reach out, visit our website. And next slide. I'd also like to invite you to our upcoming meeting. If you're interested, it's a great way to start getting involved. So we'll be meeting in Wisconsin in October. So with that, I'd really like to thank you for your attention, and please feel free at any time to reach out. We're very excited here at HACAS.
Thank you for that great overview of the Health and Air Quality Applied Sciences team and for providing a glimpse into the broad range of work that your team addresses on a day-to-day basis. Now we will hear from Pawa Gupta, who will discuss the intersection of health and air quality and the RSET program.
Okay, great. Thank you. Thank you. So today I'm going to talk about NASA's Applied Remote Sensing Training Program called RSET. The RSET provides online and in-person training to access the data on remote sensing satellites, sensors, different data sets, methods, and tools. And currently, RSET actually supports the training program in 5 different thematic areas, including disaster, health and air quality, land management, water resources, and more recently, climate is an added theme. Health and air quality, as you will see, is the oldest theme across. So I will talk a lot about health and air quality in this particular talk. The online and in-person training these are the 2 formats which we typically use. Online training typically runs from anywhere from 1 hour to 2 hours and for several weeks, depending on the length of the training. And then the in-person trainings runs from anywhere from day-longs to a week-long, depending on the nature of the training and the stakeholders involved in. These trainings are cost-free to anyone who wants to attend, although in-person trainings are restricted for the users for whom the trainings are designed. We also do have some self-guided trainings on our website. All the online trainings are recorded and available through YouTube channels, RSET. And one of the most important thing about the RSET training program I want to highlight here is that a lot of our in-person trainings are very, very tailored to the range of users in different communities who wants to start using satellite data to the advanced users who have been using the data and want to actually do more analysis or learn about the algorithms or get to the new data set. So we provide the training in range of different topics and range of for range of different remote sensing end users. Next slide, please. So just to give you a historical perspective, the RSET program started back in 2009. What you see here is the participations. Each bubble shows the number of participation in different years. And on the y-axis, you see the different thematic area under which those trainings are conducted. So just want to highlight that, as I was mentioning, the climate was just added in recent years. So you can see the number of trainings which we have conducted are limited, but we are actually reaching to almost 100,000 participants by end of this year, hoping to reach to that in last 12 years. So that is a really great achievement by RSET program. Now, if you look the health and air quality specific trainings, then you will notice that in 2009-10, we only were doing health and air quality trainings. And then later on, we started trainings on waters and then disaster and then land and other topics started agreeing. And just if we talk about health and air quality, we have reached to almost 10,000 participants from almost 180 countries and many different organizations. I think if you total those number of trainings for health and air quality, there comes around 60 plus trainings, which we have done over the last 12 years. So that's a really great turnaround for the RSET programming over the years. So if you go to the next slide, please. So what we do cover in these trainings, like I said, RSET training cover range of topics for range of users from introductions to the advanced. And this is just flavor of some of the training materials which we have developed over the year or the specific trainings which we have actually done on each of these topics. And it varies from fundamental of remote sensing. So if you are very new to the area and you don't know anything about satellite remote sensing or satellite data, this is RSET will give you a very good overview of how to get started on that. We talk about a lot of satellites which are up in the space, which are upcoming missions, how they works and how to actually use their data through imageries or the data which NASA provide through various medium. Now, I want to highlight couple of things which are really popular in health and air quality applications. One is satellite data provides you a total column value. And one of the challenges to convert that to surface for air quality monitoring and forecasting and all other purposes. And that is one of the actually very critical and a complex problem. And RSET has spent actually many different trainings, many different brings many different experts to actually explain that process and go through the exercise by using the data and Python codes to convert that column to surface in different situations. Smoke and dust monitoring has been also a very popular topic because of the increased in wildfire activities over the recent years. More recently, in last 2 3 years, we have been focusing on air quality forecasting using various NASA models and how to intercompare with the satellite data and validate those results using the ground observations. So there are a range of topics. Not all the trainings involve all of these topics, but depending on the end user need, we select certain topics to be included into certain training. Next slide, please. So in addition to that, RSET has been also doing some time-sensitive training or taking on the topics which are more time-sensitive. So just to give you some example here, which have been specifically covered in health and air quality team, sustainable development goals. So RSET was one of the first program actually providing training on how to use pollution measurements coming from the satellite observation to monitor sustainable development goal, which were developed in early 2015 and 16 by UN. Similarly, when the current pandemic started back in 2020, the lockdown all around the globe has actually forced human activities in many ways, and that actually shut down the pollution sources. So there were tons of flood of studies and media reporting on how the air pollution is changing because as a result of the shutdowns at different level in different countries. And the satellite data became one of the to-go place to look at those changes in real time because of its global coverage and real-time access. And there was several caveats which has to be considered when you are using satellite data to address these issues. And so ARSET actually did a very quick turnaround within few months to put together a specific training specifically designed to communication and media outlet folks how to use satellite data to address these specific issues during this pandemic. Wildfire smokes, we have done a number of trainings. Last year's, we teamed up with across thematic areas and did a very comprehensive training on wildfire and smokes, pre-fire, during fire, and after fires, how to manage or monitor and forecast fires and smokes. And then the more recent topic, the environmental justice. We have been considering talking with the HACAST to do a training in next years, focusing on air pollution issues under the environmental justice. So ARSET has taken lead in many of these time-sensitive topics over the years, and we are doing continuously to use remote sensing data to address these topics. So next slide, please. So just to give you a quick example of a training which we did on tools for analyzing NASA air quality model output. This was just conducted earlier in the year. You can see some statistics people have attended, but the main idea behind this training was it was a very advanced training where we used the Jupyter Notebook Python codes to analyze NASA's GEOS, FP, NASA's CF, the chemical forecast, and the MERA2 reanalysis to do hands-on exercise on intercomparison with satellite observations, validation using surface measurements, and then do a case study analysis, how to take all the data and perform the analysis to understand the performance of these models with respect to the ground and with respect to the satellite data. Next slide, please. Another quick example, this is a upcoming training which we just started registration yesterday, and this is going to be on analyzing air quality data from geostationary satellites. So you must have noticed there are a number of geostationary satellites which are providing very useful air quality data. So we are partnering on this training with NOAA and GEMS science team, which is a Korean space mission providing high resolution, spatial and temporal resolution air quality data first time over Asia. So we are working on this training, and this will be held in October. And the next slide, please. So this is just some pictures from our trainings, just for your fun. We have been in many different places all around the world to do in-person trainings, and you can see some flavors here. We have actually play games during our trainings. Also, some pictures you will see where we try to explain the principle of remote sensing and how satellite works through more interactive activities. So that's all I have, and thank you for your attention.
Thank you, Pawan. The training opportunities that the ARSET program offers are a great way to learn more about how to apply NASA Earth observation data to address a multitude of environmental concerns, including those surrounding health and air quality. For anyone that's interested, please take a look into attending the upcoming ARSET trainings that were just mentioned. Transitioning into our last speaker of this session, I want to remind anyone that if you have any questions, you can add them to the chat. Next, we have Dr. Aaron Nager, who is going to talk about tropospheric emissions.
Thank you. I appreciate it. Hopefully you can hear me okay. Today I'll be talking on the TEMPO mission, tropospheric emissions monitoring of pollution. You can advance to the next slide. All right, a little brief background on the TEMPO mission. It was selected in November 2012 as NASA's first Earth Venture instrument. You can kind of see the PI here, the principal investigator, Kelly Chance, at the Smithsonian Astrophysical Observatory. A lot of the retrieval algorithm team and experts are located there at Cambridge. The instrument development is Ball Aerospace. The project management is NASA Langley. I'm the applications lead of the TEMPO mission, And there's a lot of other institutions that have been involved, either in the science work or applications work. And of course, international collaboration, which will be talked on a little bit. And then also our host satellite provider is Maxar Technologies, and a satellite host is Intelsat 40E, and we are launching on a SpaceX rocket. So already advanced, but I'll go ahead. Some quick facts on TEMPO. TEMPO will measure North American air pollution. Oh, the slides are advancing on me. Maybe turn off is there an automatic timer on there? Okay, so hopefully we don't advance right here. So TEMPO will measure North American air pollution every daylight hour at high spatial resolution from geostationary Earth orbit. It's an imaging grating spectrometer with 2 detectors measuring backscattered radiances in this UV and visible spectrum with high spectral resolution. So you get this hyperspectral radiance information from TEMPO, and this will enable TEMPO to be sensitive to key air pollutants, including EPA criteria, policy relevant pollutants, and those pollutants that have health impacts of NO2, SO2, and ozone. TEMPO's field of regard, which is shown in that image on the slide, will cover the US, Canada, Mexico, Cuba, Puerto Rico, and the Bahamas. We recently had great news where the TEMPO integration with the host satellite Intelsat 40E was completed. This happened in June. And we had our launch is now set for late February to early March 2023 to around 91 degrees west. And our baseline mission duration is 20 months. And we are a member of a geostationary satellite constellation for observing air quality, which Pawan just touched on GEMS earlier, which is part of this constellation. Advance forward. Next slide, please. Next slide. Now I'll move a little bit into TEMPO data and operations. This is a full set of TEMPO data starting from level 1 data, the radiance level data. Of course, I'm sure a lot of the folks on the call here are really looking forward to the level 2 data products. These are those health and air quality related products, such as the ozone profile, which provide a PBL 0 to 2 kilometer ozone information. We also have total column ozone, nitrogen dioxide, formaldehyde, glyoxal, bromine, sulfur dioxide, and we have an aerosol product as well, which will incorporate aerosol AOD and aerosol layer height information, and a TEMPO GOES-R ABI synergistic product that is planned as well. Oh, it moved forward on me again. I'm thinking there's like an automatic timer set on that slide deck. Anyway, so we do have level 3 products also planned for the mission. These are the gridded version of level 2 products that I just mentioned. And you can kind of see the high spatial resolution at the TEMPO footprint of 2 by 4.7 kilometers squared for much of these products. And also these are provided at hourly resolution as well. Next slide, please. Okay, so we have a slight change or update in the operational timeline and data distribution based on our most recent launch date. So our TEMPO commissioning phase will now occur between mid-June and mid-September 2023. If we get launched in that late February to March timeframe, our nominal operations will occur 6 months after launch. We plan to have level 1B data available in January 2024, with those level 2 and level 3 products available around the March 2024 timeframe. These will be publicly available and free through NASA Earth Data Search, and the latency of these offline or standard offline products will be around 6 hours, except for the ozone profile due to the computational expense of running that algorithm. It did advance again on me. So there'd be a 24-hour latency for that ozone profile data with the near real-time products with a latency of potentially less than 2 hours for some of those key products. Next slide, please. Okay, so here's just a depiction of how, an approximation of how TEMPO will scan after launch. You see those east to west scans that are shown here. This is starting from the morning over the east coast and then advancing over the west as we gain daylight in the west region. And eventually what you'll see here is as we lose daylight in the east, you'll see that east scan line moving toward the west as we complete the scan in the afternoon hours over the west region. So this is a hypothetical, or not hypothetical, but an approximation because we'll also perform sub-hourly scans for the TEMPO mission. These will include optimized scans across the east and west during those periods when we do have a lack of sunlight in those regions, and also non-standard special operations for dedicated experiments. This can include wildfires, volcanoes, dust storms over a portion or slice of this TEMPO field of regard at higher time resolutions. So this is being planned to as part of the TEMPO mission. And I'll let that finish up there. And there you go. Next slide. Next slide, please. We'll kind of talk on the applications and early adopters program here. This has been really officially formally started in late 2018, 2019 timeframe. And we have had a really large expansion in this TEMPO early adopters program. Since that, we now have about 320 plus members across the TEMPO field of regard. This includes 50 plus federal, state, and local air quality agencies, health organizations, and NGOs. We had really great engagement with the community of practice and the community potential. This includes a recent environmental justice workshop we just had with that EJ community. And a major outcome of this program has been really an enhanced level of interest and knowledge in TEMPO and applications and skills with using the mission data across this broad community and broad spectrum of community members through workshops, focus sessions, and data tutorials. You can see the early adopters by affiliation who are part of this operation too. Next slide, please. Okay, so here's our TEMPO applications that we've designed. This is in coordination with the science team and the early adopters as well. This ultimately TEMPO will enable new and enhanced science studies, playing this diversity of application areas. We have early adopters have played a key role in expanding these application areas and sub-application areas shown in this pie chart here. And also what we've done for the early adopters community is create TEMPO proxy data. And I'll show this a little bit later too. And this really has helped enable an early understanding of the TEMPO files and data. It really helped facilitate the development of best practices and methods for incorporating that data into their science work, and ultimately to help inspire scientific experiments based on this expected TEMPO information. So you can tell the key air quality or health and air quality applications that are shown on that pie chart, including some other unique areas, application areas involving vegetation, ocean monitoring, and weather analysis and forecasting with our water vapor product. Next slide, please. Okay, some examples here of our TEMPO proxy data. I stitched together 10 different TEMPO granules of information and made a full field of regard image here for using our tropospheric proxy NO2 product at the top there and our total formaldehyde product at the bottom. And what you're seeing here is these enhancements of wildfire smoke plumes in particular, with these enhanced NO2 columns in the west, and also those same plumes are showing up in enhanced formaldehyde as well in the west region. And we're also seeing some biogenic sources popping up there in the southern area of the US in the formaldehyde map. So we've created this proxy data, and we can continue to do so for the early adopters community. Next slide, please. So we're here, I'm zooming in on California in the west here, and I put together hourly animations of tropospheric NO2 and total formaldehyde for one day. And one of the key aspects of these animations here is a wildfire smoke event that occurred over California. And you can see those highly evolving NO2 and formaldehyde columns associated with this wildfire smoke plume. And this is when occurs in the afternoon hours when this peak fire intensity generally occurs. So TEMPO had that capability to have that rapid monitoring of wildfire smoke plumes in the afternoon hours when we currently don't have that low Earth orbiting data available. And ultimately, TEMPO's ability to monitor these highly evolving emission sources will be unprecedented after launch and will help better characterize emissions across the field of regard. Next slide, please. Here's an example of our TEMPO ozone profile as well. To the left is our 0 to 2 kilometer, what we call our PBL ozone product, and in the middle, the tropospheric ozone product. So this is, again, an hourly animation zoomed in on the east of the US. And ultimately, this shows the ability of TEMPO to track ozone pollution in this tropospheric layer throughout the daytime. And this also shows the sensitivity that TEMPO have to ozone pollution in the lower troposphere and PBL layer where people live and breathe. So this will be unprecedented information for the community and to help better characterize ozone pollution, and impacts on health after launch. Next slide, please. And I do want to highlight this Tempo Special Operations. This is, I mentioned it earlier in that field of regard scan, but up to 25% of Tempo's observing time will be devoted to these special operations with sub-hourly frequency over slices of the Tempo field of regard. These can be done for air quality disasters, just wildfires, dust storms, volcanoes, industrial accidents, and research studies. This includes lightning knocks, for example. These preloaded scans can be easily initiated a few days prior to the event, with the possibility of zooming in and targeting events a few hours prior to that event. And these can be done and initiated during the commissioning phase. So we can potentially begin to conduct these in June through September 2023. Next slide, please. And of course, we have this living Tempo green paper where we're actually specifying these special experiments as well. So we welcome those community members to contribute to this green paper, and you actually submit a request for those through our link on our site. And of course, the great part about this is to become a co-author with the rest of the Tempo team on this living green paper. And we're doing these coordinations and this planning now for these operations. Next slide, please. And I do want to note this recent success we had. This was actually a collaborative effort, co-led by myself and Abby Naston, who is the applications lead at Maya. And we hosted a NASA Aerothon crowdsourcing challenge. And the overarching goal of this challenge was to develop unique algorithms using Earth science data in preparation for Tempo and Maya to retrieve this accurate surface level NO2 and PM2 PM2.5 amounts, which are key Tempo and Maya products after launch. And the problem here, the problem statement, was that no current NASA satellite mission. Oh, it advanced on me again. Sorry about that. Okay, so no current NASA satellite mission provides these ready-to-use data products on the criteria surface level air pollutants with low enough latency to protect public health. That was one of the major motivations of conducting this challenge. This had tremendous engagement from the community with over 1,200 submissions and more than 1,000 participants, over 123 countries. And you see the first place prize award winners here on the slide. Overall, the challenge winners and use tree-based ensemble machine learning models, for the most part, to accurately estimate surface level NO2 and PM2.5 concentrations. For NO2, participants were able to use OMI and TROP-OMI data, along with auxiliary information. The winning solutions and lessons learned from this challenge will be used by the Tempo team as we generate technical resources and air quality products for the user community. And the U.S. Department of State was actively involved in this competition as well. And they have interest in applying these methods from the winning models to provide air quality information to its employees and the general public at various embassy locations in the future. So next slide, please. I do want to note the preparation for data services for Tempo. We have this Tempo proxy data. We've actually already put this into NASA Earth Data Search. Early adopters in the community are able to actually download Tempo files like that will be available after launch. And you're seeing a screenshot of one of our Tempo workshops recently where we showed the users and the early adopters how to download Tempo files pre-launch. So the users have really been engaged in this. We have proxy level NO2, formaldehyde, and ozone products currently available in NASA Earth Data. And we're also thinking about this development of enhanced data services at NASA to expand the breadth of the Tempo users and applications. This was highlighted also in our recent EJ workshop with that community. Next slide, please. I'm about done here. This is one of my last slides. So some recent early adopter activities. We had data tutorials where I showed that example of us sharing the Tempo proxy data in Earth Data Search. That was done in our proxy tutorials last fall. We've had joint meetings with the Tempo science team in HACAST in June of this past year. I've also been engaged with technical meetings with Tempo, involving Tempo, with air quality agencies. This includes the National Tribal Air Association / EPA and EPA. And we had a Maya Tempo EJ workshop last Friday, which was very well attended. We had over 150 participants, and many of those were from the EJ community. And I'm sharing some screenshots here of the Tempo science team participants from our meeting in fall, and also kind of a an intro slide deck from our EJ workshop last Friday with this catchphrase, measuring gaseous and particulate air pollution at unprecedented resolution, which will have that capability with Maya and Tempo data after launch. Next slide, please. And last note here, Pawan already mentioned GEMS, which was launched in February 2020, and we have Tempo being launched in 2023, coming up soon, and we have Sentinel-4 from the Europeans, planned for launch in 2024. So we have this geostationary air quality constellation being developed and will be in flight soon, in space soon. And here's some examples of recent GEMS products. These data files actually are available now, at least for the SO2 and the ozone. So I'm sharing examples here of those hourly GEMS products for NO2, formaldehyde, SO2, and ozone over East Asia, in this area of the globe that's highly polluted and has major health impacts from air pollutants. Next slide, please. And I'll end there. I thank you for paying attention and being here today. Of course, we have our early adopters community link right there if you're interested and want to sign up. And you can find more information on our early adopters site and on the Tempo Mission site as well. And thank you.
Thank you so much for that engaging presentation describing the benefits of Tempo. I encourage the audience to look into the resources mentioned in the last presentation to learn more or to join the early adopters community. That concludes our health and air quality application session. Thank you to all of our speakers one more time. And thank you to all of you who attended the session today. We hope you'll join us after a short break for our next section focused on equity and environmental justice initiatives. And we also hope to see you for the rest of the events scheduled throughout the week.